What PMAP does is, because we were trying to do something different from a chemistry perspective, and the chemistry is more expensive than the incumbent in traditional lime, we needed to flip the system upside down. We didn't see AI as purely something fancy and something new and something novel. We asked ourselves a simple question: how can we use this new technology to do something completely differently? So what our process basically is we have the autonomous boat with a number of different sensors that will go into a water body, whether it's a tailing pond or a pit lake or something like that. We'll create a digital map of the pond so that we know exactly what it looks like, and we'll do readings, whether it's pH, TSS, or whatever is required, and create like a full 3D representation of that water body. We'll create a custom plan. That custom plan then allows us to make sure that the chemistry that we dose into the pond is directly at specific points where it's needed in the pond. This allows us to reduce the amount of chemistry that we need and increase the efficiency of the reaction in the pond. Over and above that, we're also using generative AI to help us speed up reporting and all of that kind of stuff, which I'm sure a lot of people are in some way, shape, or form. But we're not really using AI as something flashy, and we're rather saying, how can this enable our technology in a new way? They also tried a slightly different approach where they said, we've got all of this data that we have available to us sitting within our cloud. How can we look at that data and interrogate that data in a really, really interesting way? So I think it was one of the consultancies, I think it was McKinsey, that worked with them to look at that data and see how they can increase the operational efficiencies within that operation. They were able to increase their production capacity by, I think, about 5 to 10% per year. And what that related to in sort of dollars and long-term sustainability for that operation is that within the 5-year period, they'd be able to produce as much value as it would cost them to create a new processing plant.
The things that I'm excited about for the industry are things like autonomous vehicles, asset management and predictive maintenance, AI-enhanced machine vision, which really unlocks a lot of opportunities, as well as operator expertise condensation and data analysis, as well as real-time process control and optimization. So at Mintek, we're quite excited about our self-learning agent, which is quite robust, and that's been able to eke out quite a bit of benefit over an already tightly controlled milling circuit. Unfortunately, this means that it's easily outmaneuvered and outsold by these tech companies and the tech pros selling these flashy innovations. There's a lot of unease between bridging networks and information from different sources across different protocols and from different networks, between operational networks and IT networks and the internet. So this is already giving us a bit of a shaky foundation. The next factor I think is also very important is base layer control. We need to make sure that the plant is fundamentally controlled well. Firstly, to reduce the variance that's obscuring data-driven models from finding the actual physics of the process, and also to make sure that these technologies actually have a steering wheel to drive the process to where it needs to be, reliably and accurately.
Digital twinning, I know, is becoming a little bit of a buzzword, but it is a very useful tool. We've already been working, so something that has already been piloted and proven to be useful, arising from some of our work, is digital twinning for proximity detection.
I mean, data. Everything is about data. AI is about data. In exploration, this is not an exact science. This is really exploration. And it says either from grassroots exploration to mining or brownfield, we call around the mine. Today, with this, we just do that, and within 24 hours we know. But that's still inexact. AI will not find mines. AI will help you to define the targets, to define mines. Okay? At the end of the day, maybe you'll squeeze the time, maybe, but then you can also waste a lot of time and a lot of money. But for us, for example, just to give you an idea how it's different, although we're Canadians, we have 100 people. I mean, the seismologists, scientists mainly, but few exploration people, But all the people, the data scientists, they're located in Colombia. Why? Because they all geophysician, super, and they cost me 50% of the price. And in Canada, and they are as competent. And all my geologists, that the guy that modelize in this, those are people who work with me for over 25 years, and now they adapt themselves with the young. They're all located in Peru. And we cover the entire world like that.
I mean, a minute in a production cycle equates to X amount of million per year. And getting the data to a decision quicker, that's what we want to achieve in every single thing we do. So, go back to the basics, flow processes. Sharing backbone infrastructure is a very critical part for us. And trying to make that easier for those small, medium miners, more cost effective, where they are for large workforces, and give them just a little bit more information. 10% information in those operations are worth a huge amount of money.